wants us to find the statement that best represents the domain of this graph. So whenever I think about domain and range, first, make sure you know what you're thinking of. For domain, we're thinking of the x's. For range, we're thinking of the y's. I like to usually think about it as what is the smallest x, or what is the smallest y, and what is the largest x, or what is the largest y, depending on what I'm looking at, domain or range. In this case, we're looking at domain, so we're looking at the x's. So I'm going to be thinking, what is the smallest x value possible, and what's the largest x value possible looking at the x-axis? Since this graph is going forever to the left, indicated by this arrow, I know there isn't a smallest x value, or you could think of the smallest x value as negative infinity. So this isn't how we write our domain and range in the STAAR test anymore, but at some point in time, we did write negative infinity in the way we would represent domain and range. And then I set up a double-sided inequality. From here, we're going to look for the largest. The largest x value is 5, so I'm going to put 5 on the other side of this double-sided inequality. And then I need to look at this dot. Since it actually stopped here, if it's an empty dot, it will not actually equal 5. But if it's a solid dot, it will. So I'm going to put an equals to line underneath that. I mentioned a little second ago, or a couple seconds ago, that we don't really write the negative infinity when we do our inequality notation. So I'm just going to scratch that out. But it helps you set up the domain or the range. If you build a double-sided inequality, put whatever the smallest is over here, the largest on the right, and then scratching out the infinity side, you can get your domain written as an inequality. This reads as x is less than or equal to 5, so we're looking for the one that says all real numbers less than or equal to 5.